Have you heard there will soon be a super blood wolf moon total lunar eclipse? What is it, you ask? Well, unless you're an astronomer or you study the moon, the answer can't be complicated. Don't worry, though. We have an expert here this morning to explain. Welcome, Crewe, who is the planetarium expert from the Carnegie Science Center. Okay,
Hello.
What are we talking about, Ralph?
So there's a lot of stuff going on there.
Yes.
So why don't we take it apart piece by piece? First of all, a supermoon is just when, and we've got a very technical model here of the Earth. We'll call this the Earth and the moon. A supermoon is when you have a full moon, when the moon is also in its point in its orbit when it's closest. So as the moon goes around the Earth, the distance between the two changes a little. If it happens to be full, when it's closest, we call that super because that's when it looks the biggest. But the difference is actually relatively small, about a 14% bigger moon than average.
Really?
But the other thing I'd like to demonstrate, if you would, is the distance between the two, because they're actually a lot farther apart. On this scale, this is an 8-inch wide Earth and a 2-inch wide moon. How far apart do you think they would actually be in space? Like make an actual
Not
scale
this close.
distance.
I'm going to say about right here, maybe.
That's not a bad guess, but you'll have to go a little bit farther.
Farther.
So
all right, let's try this. I'm going to step away a little bit.
A little farther.
Farther than this.
Yeah, actually, you're going to have to take quite a couple more. Maybe 4 more steps.
Okay.
About there. Yeah, right about there.
Wow.
So on this scale, this is an 8-inch wide model, you got to be about 20 feet away. That's the distance between the Earth and the moon. And what I think is amazing is that was covered by Apollo astronauts.
Yes.
And when we think of astronauts going out to the moon, you know, that's pretty impressive. We're coming up on 50 years of that. But the astronauts on the space station are much closer to home. They're not like here. The space station orbits about this far away.
Really?
Yeah, it's just a fraction of an inch away off the surface, which I think is cool.
Took a while to get to the moon, and now we know why. Okay, I'm going to come back.
So we understand the supermoon because the moon is full when it's closest. The wolf moon comes just from the moon in January. The full moon of every month has a nickname. Something that's been used in farmers' almanacs for centuries. And the January full moon is called the wolf moon. It's associated with wolves howling at the moon in the middle of winter. And then we've got the blood moon and the total lunar eclipse, which are actually the same thing. And I can demonstrate that, but we'll need to bring the lights down because we have a model of the sun set up. And I'd like to show you essentially what's going on here. So imagine the Earth in space casting a shadow. Thankfully, this wall here can demonstrate that shadow. Now, as the Earth is in space, the moon orbits it, and the moon will often come just above the Earth's shadow or just below it because the moon has a bit of a tilt to its orbit. But if we're really lucky, and keep in mind, this is in real life 20 feet apart, really far apart. If we're really, really lucky, the moon will hit right into the Earth's shadow. And for about an hour, and we have one of these coming up on Sunday, for an hour, the moon will be in the shadow of the Earth. Now, when that happens,
lunar eclipse.
That's right. That's exactly what a lunar eclipse is. Now, when that happens, the light, you would expect it to be black, right? Like here, we see the moon just goes dark. But the Earth has an atmosphere around it. The air around the Earth acts as a lens, and it bends light, so there is light that actually makes it around the Earth. And that light is also filtered, so we see only certain colors, typically red.
Wait a minute, let's stop. So the atmosphere around the Earth.
The air around the Earth.
That's the lens, and it bends the light?
Is functionally a lens. It bends light, it refracts light around the Earth. It also scatters that light, preferentially by color. So the color that makes it to the moon will be the color of a sunset. You know, when the sun's setting, you see that beautiful deep red color?
Yes.
Well, if you were standing on the moon during the lunar eclipse, you would look at the Earth and see every sunset and sunrise at the same time. And that will color the moon a deep blood red color. And it'll be that blood moon color for about an hour, starting at about 11:40 on Sunday.
So 11:40 Sunday night?
That's right.
Correct? And so we're looking at a picture of it now.
Yes.
How often does this happen, Ralph?
Well, we won't have another one here in Pittsburgh that we can see. Actually, in all of North and South America can see this, but we won't see another one until 2022. So it's rare. It's not as rare as a solar eclipse. Now, a solar eclipse is when the Earth and Moon are lined up the other way around, and the Moon is casting its shadow on the Earth. Now, the Moon, of course, much smaller.
Much smaller, yes.
Casts a very small shadow. Famously, we had an eclipse.
2017,
Yes,
I think?
in August of 2017. And the shadow, the darkest part, or the umbra of the shadow that hit the Earth at that time, was only about 30 miles wide. Whereas the Earth's shadow covers the whole moon. The moon's shadow just casts a little dot on the Earth.
Because the moon is much smaller.
Because the moon is smaller. And keep in mind, the distance between them is tremendous.
And you were saying to me the distance, if we had the sun into this.
Yes, on this same scale, the sun would be over 70 feet wide. Right? So it would be as wide as the studio here. And it would be 1.5 miles away. So it would be, it would be so far away that you imagine a 70-foot ball looking about the size of the sun in the sky, about the size of your thumbnail outstretched.
That sun is something else. Okay, so you guys have something coming up Sunday so people can see it. Tell us about that.
So we have a very special event, a special edition of our SkyWatch, which is an astronomy program. We start at 9 o'clock. We'll be running our Planetarium, where we can see the stars and the planets, the constellations, galaxies, and more. We also will have Point View Hall, our fantastic brand new event space in PPG Science Pavilion, open. And we'll have telescopes set up there. And we'll be going until 1 in the morning.
Wow.
Observing the moon. And even if the weather's not great, we'll be live streaming it. And we'll have multiple astronomical demonstrations. We'll have staff members there on hand. And tickets actually have been selling very, very quickly for this event.
Okay, and so tickets are $2, is that right?
They are $4 or $2 for members, or as an add-on to admission. And we actually look like we might be selling out. So if you're interested, definitely pick up your tickets sooner than later.
Wow, well, this is fascinating. Thank you so much for that demonstration, for that lesson. Our thanks to Ralph Crewe from the Carnegie Science Center for today's lesson. To get the details on the SkyWatch of the total lunar eclipse on January 20th, visit kdka.com/PTL.